Good morning, students. Today we are going to be going over Unit 1, Lesson 3 in our units of basic geometry. Today we're going to be talking about measuring segments. Our standard today says to know precise definitions of angle, circle, perpendicular line, parallel line, and line segment based on undefined notions of point, line, plane, distance along a line, and distance around a circular arc. The parts of this lesson that are going to be really important are knowing the precise definitions of line segment based on points, lines, and distance along a line. Those are the key takeaways from the standard for today's lesson. Today you're going to be able to identify point, line segments. We're going to differentiate between lines and line segments. We're going to generate a precise definition of line segments and then solve mathematical problems using the segment addition postulate. Some key vocab. You've already learned what point, lines, planes, rays are. Today we're going to be talking about line segments, which you learned a little bit already, but we're going to go into some more detail. We're going to talk about the segment addition postulate. We're going to talk about distance and length, congruent segments, which we'll get to tomorrow, collinear we'll get to as well tomorrow, and segment bisector, something that we'll get to in another lesson. So let's understand the precise definition of a line segment. Line segment is a set of points and has a specific length. It does not go on indefinitely. That means it does not go on forever. The way that we identify it or name it is by 2 points, and it always has a certain length that we can actually measure. We can measure with a ruler, or we can measure with other means. So this whole thing with our 2 arrows on the ends, we already learned is a line. But when we identify 2 points, point A and point B, this here is something that we can measure. It's the first thing in geometry that we can actually measure. That is a line segment. The way that we would name it is by calling this line segment AB, and we would draw a line over top. Or we could call it BA and still draw a line over the top. This stands for line segment. This also stands for a line segment. How we find the length of a line segment, we can use a number line. And basically, we're just figuring out the spaces between them. Two line segments with the same length are said to be congruent line segments. So congruent means they have the same measure. The way that we notate that is by these lines here. So line segment AB is congruent to, which means it has the same measure as line segment WX. If line segment CD and line segment YZ are the same, we could put one line. That means these two have the same measure. These two have the same measure, but AB and CD do not have the same measure, because this has 2 lines, this has 2 lines. Both of these just have 1. And then BC, maybe we can put 3, and this one we would put 3. So now this measure and this measure are the same, but this one and this one and this one are not the same. Find the length of each line segment. So we want to find the measure from A to C. If there's a line over it, that's for the picture of the line segment. But if we just want to know the measure, the number, using a ruler or a number line, we do not put the line over top. So from A to C, right here, we can count 1, 2, 3 spaces. For CP, this distance from here to here, we can count 1, 2, 3, 4, 5, 6 spaces. H to L, this line segment, we count 3 spaces. And A to L is this whole distance. If we count those all, it would be 10. Or, instead of counting, we can subtract numbers. So from A to C would be from -5 to -2, and we come up with the absolute value of 3. And you could do that for all of them. Notice that AC and HL both have a distance of 3. So AC is congruent to HL. Now let's talk about the segment addition postulate. Segment addition postulate says if 3 points A, B, and C are collinear, this word means that they're all on the same line. Co means together, and together on the same line. If A, B, and C are collinear, and B is between A and C, then this distance plus this distance equals the whole distance. AB plus BC equals AC. Another way to think about that is this part plus this part equals the whole thing. Or we can say that this part plus this part equals the whole thing. So another way of thinking about segment addition is part plus part equals the whole. So let's draw some pictures and go through some problems. Find the length of each segment using the segment addition postulate. Draw a diagram. Or draw a picture to show this. So step 1 is to draw a picture. Point Z is between T and C. They are collinear. So step 1 is to draw a line. Z is in the middle somewhere. And you have T and C. The distance from T to Z is 3 centimeters. And the distance from C to Z is 12 centimeters. What is the distance from T to C? So this whole thing. So we would say TZ plus ZC equals TC. Part plus this part equals the whole thing. And now we can substitute this number in and this number in up here. So 3 plus 12 equals TC. Well, 3 plus 12 is 15. So 15 is TC. And then don't forget we want to include our units. So over here our final answer, 15 centimeters. Let's do one more, and you can practice this one on your own with your table partners. I'll come around and help. At this point, I would, pause, conference, walk around the room, and then we would go over the problem together. In this problem, we have Q to K. Let me read it. So sorry. Point S is between points Q and K. The points are collinear. So first step is to draw our picture with S in the middle, Q and K on both sides. We have, in this case, we have the whole thing, and we have this part. This is the part that we're trying to find out. So we're still going to do this is our whole is equal to our part plus our part. And now we get to substitute in the parts that we do know. We would say that 24 is equal to 10 plus SK. And now this becomes an algebra problem, just like you learned last year in Algebra 1. To get the answer for SK, we would subtract 10 from both sides, and that's how we would come up with this answer here. Oops. The SK is equal to 14 centimeters.